Okay, polynomial expressions review. This is one of the shortest assessments in this whole class. Okay, so, alright, simplify the following expressions. You're not solving for any letters, you're simply simplifying. Now, all these are P1, P2. Now, you got to know the operation. You have a plus on this one. Okay, so let me read it. 4m to the second minus m, that's a 1m, plus 2, that's P1. Plus negative 3m to the second plus 10m plus 7. Since I said plus and minus about 6 different times, you should not go with the 3 lines. You want your P1, P2 rules. So this is adding right there. So we don't be doing a bunch of rainbow. You don't do that. You go right to your slots. So when I look through this whole thing, m to the second is the highest we have. And no, you are not adding the exponents to m to the fourth. That's a multiplication thing. We are not multiplying. Then plus slot m plus constant slot. So m to the second, we have a 4 here and a negative 3 here. So we take 4 plus negative 3, that's 1. Okay. And then m, negative 1 plus 10 is 9. And then constants, 2 plus 7 is 9. That's the end of the problem. Okay. You will be docked if you put that as m to the fourth. Okay. That is a multiplication thing. This is not multiplying. Okay. Number 2, we have 9x to the power of 3 minus 13x to the power of 2 plus 1x. Minus negative 13x to the second power minus 5x plus 14. Okay, well, we have a minus sign, okay? So, again, you're not distributing, okay? You're using P1, P2 rules. You're doing it the same way you did up here, but you're making the minus a plus, and everything in P2 goes its opposite. So plus, positive 13, the coefficients do, okay? Positive 5 and then negative 14. Okay. Now, as I look through the whole problem, I have x third, x second, x squared, x constants, x third's the degree. So high x third plus blank x second plus blank x plus constant. Okay, x third, I have a 9 in P1. I don't have any of x to the third power terms in P2, so that's 9. X second, I've got a negative 13 in P1, a positive 13 in P2. Negative and a positive, the same thing, always add to 0, so that means that is canceled. Okay. Then x, we have a 1 and a 5. Okay, 1 plus 5 is 6. Then constant, we don't have any constants in P1, we just have the negative 14 in P2. Okay. That's adding and subtracting. Now, you have 3x to the third, that's a 3. Put that in parentheses, and then that's your P1. Then P2, you have 8x to the fourth minus 1x to the second minus 3x plus 5. So now there's no symbols between the parentheses, so that's a multiplication. Okay? So, P1 times P2. Well, now I start distributing. 3 to 8, 3 to negative 1, 3 to negative 3, 3 to 5. So I will be taking the 3x to the third times the 8x to the fourth. Actually, just write 3x to the third out 4 times. There's one person in period 1 that doesn't write it out. They just find the products, and that's fine. Just make sure you don't overlook, okay? And then 3 times negative 1, x to the second, and then negative 3x, and then 5. So you find these products. So 3 times an 8 is 24. Now you add the exponents because you're multiplying. So 3 plus 4 makes 7. Okay. 3 times negative 1 is negative 3. Then on x, 3 plus 2 makes 5. X to the fifth. You need to put the x down, though. 3 times negative 3 is negative 9. Now, we have to take the x to the third power times the x. So, we probably want to put a 1 on the x so that we know we're adding a 3 plus a 1, and that's 4. Okay? Then 3 times 5 is 15. Now we just have this x here. It doesn't get multiplied, it just gets attached to the product with its power of 3. So when I look through all those, the degree is x to the 7th. That's the highest. Now before I slot the other ones, I'm not going to make a slot for x to the 6th. Why would I? I don't have it. X to the 5th is there. X to the 4th is there. And x to the 3rd is there. X second is not there, x is not there, and constants are not there. So and for x to the 7th, we just had the 24, so we will not be adding anything. For x to the 5th, you have the -3. Remember to put pluses between these. Don't be putting times dots. Okay? X to the 4th, you'd have a -9, and then 15. By the way, when you line up your slots, they should go in order. Okay. For example, x 7th, okay, and then they should decrease. Should be highest to lowest. Okay, next one, number 4. P1 is 3x minus 1, and then P2 is 4x plus 9. Remember, P stands for polynomial, and this is times again, so you're going to be doing some distribution. So first I distribute the 3x to the 4x and the 3x and 9. This is known as the FOIL method here because you're finding 4 products. You can write this, I don't care, but that's what the name of it is when you're multiplying 2 things by 2 things. Okay, then times 4x times 9. Now I repeat the process with my -1. Okay. Three times 4 is 12. Now remember, when you take an x times itself and there's no powers on either one, it takes us to x to the 2nd. Because it's like a 1 plus a 1. You really need to know that I don't care if you put 1s if the other one's got an exponent, but try to get down that a letter times itself is to the 2nd. It helps in the next unit big time. 3 times 9 is 27, and then just x. -1 times 4 is -4x, and then -9. So I'm looking through those products. I have x to the 2nd. I've got some x. And I've got constant. So I've got all 3 of them. So x second, you just got your 12. It's the only x second term you got. X, you have a 27 and a -4, so those need to be added. So 27 plus -4 is 23. And then -9. There's your product. Number 5, P1 is x plus 4, 1x plus 4, times P2, we got 1x to the 2nd plus 6x minus 5. So it's the same as last time, it's just a little bit longer. Okay. So 1x, 1 to 1, 1 to 6, 1 to -5. And 1x to the 2nd, 6x, -5. So that's the end of 1x. Now 4 to 1x, 4 to 1, 4 to 6, 4 to -5. 4 is a constant. So 1x to the 2nd. Same 3 things actually. I mean, you look at your first things, you just repeat it. So find the 6 products and put together necessary. 1 times 1 is 1, so now I have to multiply the 2 x's. Now if this has a second, this has a first then. Okay, so it's x, 1 plus 2 is 3, so 1x to the 3. 1 times 6 is 6, and then x times x is x to the 2nd. 1 times -5 is -5, and then x. 4 times 1 is 4, we put x to the 2nd. If you only have one x, a single x factor, you just put it with its power. 4 times 6 is 24, single x factor, just put it. 4 times -5 is -20. So now we have the 6 products. I have x third, x second, x second, x constant. X thirds as high as we got. Then we do have x second. Put pluses, not times dots, because now the multiplication's done, okay? And then plus x, then plus constant. So x third, this is the only time I see x third, so it's got a 1. x second. Now, don't add the powers on the x's now, okay? You're done multiplying. So now you're just adding, and when you're adding, you're not adding the powers. You're just adding the numbers in front. So you have a 6 and a 4. 6 plus 4 makes 10. Then x, well, I've got negative 5 and 24, so I add those. Negative 5 plus 24 is 19. And then my constant, negative 20. Now, this one gets people. They don't know how to handle it. So 3x plus 5, and then the second power. You're not making the 3 lines. I said the word plus right here, okay? So we're not, when you got plus and minus within the expression, then this is no longer the 3-line rule. It's not an exponent properties problem. It's a polynomial problem. So P1, then you make another parentheses, and P2 matches P1. Now you just apply the FOIL method, okay? It's multiplication, 3x to 3x, 3x to 5. And then 5 to 3x, 5 to 5. Okay, so 3 times 3 is 9, x times x, x second. 3 times 5 is 15 with x, 15 with x, 25. Okay, so x second is your degree. When I say degree, it's a starting x and then the constant. So x second, you got your 9, that's it. X, we got a 15 and a 15, that adds to 30. No, it doesn't add to 0. It only has a 0 for positive and negative, then you have 25. Okay, and you have one story problem here, okay? We did an assignment with these. A picture has a length of 20 inches, a width of 25 inches. We're going to build a border around the picture. First thing you want to do is draw a picture. It's talking about a shape, 20 and 25. If you have the 25 and the 20 in different places, that's fine, okay? Now, you're building the border. Now make a line measuring the length. Now the middle part is 20, but these outer parts are used as with an x variable, okay? Middle part's 25, x variable, okay? Write a polynomial expression that represents the total area of the picture and the border. So A equals, and then you're going to make 2 parentheses, times, with the times operator, because area is equal to length times width. So length, you're going to put 1 and 1, so you combine the 1x's by adding. It does not go x to the second because you're not multiplying yet. You're adding. A 1x and a 1x makes 2x plus 20. Then 1x is 2x plus 25. Now multiply that stuff out, okay? So you distribute your 2x to each term. 2x times 2x times 25. Okay, now we distribute our 20. Okay, now it's really not a story problem anymore. Now after I set it up. Okay. So 2 times 2 is 4. X times x, x second. 2 times 25 is 50 with x. Then 40 with x. And then 20 times 25 is 500. Okay, so x second is the degree, and we have some x, and we have constant. Constant means there is a number, a product that didn't end up with a variable. So you got x second, you got 4, x 50 plus 40 is 90. You add these two, okay, and then 500. Okay, that's the end of part A. Part B is pretty easy. Use your expression to calculate the width of the frame. That's 4 inches. What that means is we substitute x equal to 4. That means those x's up there are now 4s. 4, 4, 4, 4. So A, empty your x's. Remember to put an exponent and just put empty parentheses. This needs a second, then plus 90, parentheses, plus 500. Now we insert the 4 value into the parentheses. Okay, so 4 parentheses 4 to the second, whoops, caret 2, okay, plus 90, parentheses 4, plus 500. I got 924, so A equals 924 inches, but it's square inches. You can put square inches, you can put it to the second power, I don't care what, okay, square means second power, but yeah.